Oh, morning everyone. In our previous class, we briefly learned about Node.js inbuilt modules. So we learned about the file system and some inbuilt modules that can be handy. And in today's class, we're going to be building a Node.js app from scratch using just Node.js and no external library. So we don't have much slides today. We just have one. But this is what we're going to be doing. We create the project, create the package JSON file, we scaffold the project, we create the project structure, that is every other thing within the project. We create a README file, we create the binary directory, the source directory, and other directories inside the source, which are commands and utils. So without wasting time, I guess we should just start. Okay, so first of all, we need to create a directory for our project. We call it task manager. We call our project task manager. But before we even create a directory for our project, one second, please. Okay. So sorry about that. Just trying to figure out something. So first of all, look at today's class overview. So what we are going to be building is actually it's just a command line interface app. So this tutorial here will guide you through building a complete CLI task manager using Node.js with ES modules. So by the end of this class, you will have a fully functional command line application with no external dependencies. So the learning objectives for today is to understand Node.js CLI application architecture with ES modules. We work with the five system operations. We implement command line arguments passing. We create modular maintainable code with modern JavaScript, and we handle user input validation as well. What we're building is actually a professional command line interface with colored inputs. So before we even started the bootcamp, I specified things you need, the prerequisites, that Node.js version 22 or above, and a text editor. So after, if you actually want to build, you will need all of those. Okay, so moving on. We'll go ahead and create our project directory. So we're in KodeCamp 5 directory. So we'll create we'll call it task manager. And we'll go into our task manager. So there's nothing inside our task manager. So what are we going to do? We'll first of all create a package.json file. And we run npm to create a package.json file on the command line. We do something like npm init -y. We hit enter. So let's expand our task manager directory, and we see that we now have a package.json file in our task manager. So what we just did is the package.json contains metadata, scripts, and dependencies for application. So it keeps tracks of metadata and scripts for application. So if you run something like npm init, then it will prompt you to, okay. Yeah, so it will prompt you to enter these options manually. But then if you append it with -y, it will create the package.json and accepting all the defaults. So that was the reason why I used y. So we can accept all the defaults. We have a task manager version 1.0. The main file is index.js. So moving on, we want to actually populate our package.json. So let's first of all, we have our version number here. Let's add a description. So in this description, this will describe what our app is doing. So basically we say a comprehensive should we say command line task manager or task, let's make it task management system like this. Okay, so there's a description here. We'll remove this one. Okay, so now that we have a description, we specify our main file. Our main file should be, we're here to create our source directory, but it should be here, source/index.js. This is our main file. The type, we're using ESM. So the type here should be module. So we specify our binary. This we instruct this, we tell this app where our binary file actually is. So we see bin, this is an object, and it will take, this is the name of our app. This is what we'll be running on the command line, say task manager. And then we say it is in this directory, that is /bin/task manager JS, like this. Now we have other things like script, keyword, author, license. We have license here. Let's change this license to MIT. So our project can be open source and other people can contribute to it as well. So let's move the license to the top. Let's say here. Let's also move the author. to this place. Let's move the keyword here. Okay, so what should the keywords be? The keywords should be let's see, CLI and task manager, like this. So the author should be, when you create this, it should be your name. In this case, my name is Christopher S. Onduna, and you can reach me at either mean at this, or my website is my website.com. You can see example at gmail.com, like this. So this is basically it. So now that we've populated our package JSON file, we also need to specify engines, so that if the machine we are running our application on, if it doesn't match the requirement, like it doesn't meet the requirement, it shouldn't run. So we should say like engines, and the engine here will specify node, and node should be greater than or equal to version 22, or let's leave it like this. Great. So we have our mini package JSON for our CLI app. So the type module here enables ES modules throughout the project. So I actually added this manually. Then this bin here tells NPM that this is a command line interface tool. So the engines specified NodeJs version requirement, and the scripts provide convenience commands that we can use to run our app. So let's create other directories that we need. So we're going to be giving a command mkdir -p. Let me see. This p here means, okay, let me just create and write it first, and I will tell you what the p means. /command /utils. And finally, the binary directory. So what this p here means, as we are creating these directories, if the parent directory doesn't exist, create it. But if it exists, just ignore it and create the subdirectories. So here we don't have the source. That's why we are specifying this p. So it will create the source, then create this command inside the source. Here as well, it will create this utils. After this, it will see that the source directory exists, and it will create the utils directory inside the source without creating the source anymore. So if you run this, we can come over here and see that we have the source with commands and utils, and we have our bin here. So we successfully created directories for our app. So this structure here, it's very simple. So this is our command line entry point, this bin here. And the source here contains our source code. So this command directory here houses our individual commands for this app. And the utility functions are also housed in this utils directory here. Now we will make a file. We make a file in the source directory, which is index.js. This is our main application. The index.js is our main application. Okay, so now that we have our main application, we have a README in here. No, this is outside of this. Okay, so we create another file. We say touch README empty. So this README MD here, we hold our docs, some other things. So what the commands directory be doing, the utils and other directories. So the utility directory handles all file system operations. So we use NodeJs inbuilt FS promises because we are using ASM, not CJS. So even if you use the promises, it won't throw errors. Okay, sorry about that. Okay, so this is not open. I don't know. Okay, so now that we have a basic structure of our application, we move on to the utilities directory. This is what we'll first work in. So first of all, we need a file in this utils directory here. I will call it file manager JS. So in this file manager JS, this is where we'll be managing our various files and like where we'll be storing our data, where we'll be storing our task and the rest. So we'll make sure we create our directory. If it doesn't exist, then we write our task to it and we write other functions that will handle all these operations. So let's get to business. So first of all, we need to import some couple of input modules. So we'll first of all import from FS. We can see node FS. So in here, instead of importing FS direct, we say promises as FS. Then we rename it as FS. Instead of doing something like, okay, we can come over here and do something like import node FS slash promises. So we don't want to do that. We just import it as a named import and then rename it to FS. So we also import path like this. So we also need other inbuilt modules. We import file URL to path from URL. We also need OS, import OS from OS. And for some of you that attended our previous class, we already know we have a basic understanding of some of these inbuilt modules. So first of all, we grab the file name. So we do something like const file name is equal to file URL to path, and then we say import meta URL like this. Okay, so now let's log this to the console so we see what we are doing. File name. Now if we come over here and then we run node source utils file manager JS file URL to path. Okay, file URL path. Okay, so I think this is, it should be URL, and here should be URL like this. So we can try this once more. Okay, so you can see this is the file name. This is the whole, this directory is the one pointing to this file. As you can see from here down to the file. So we want to extract the directory. Now, if you do something like, the reason why we're doing this is because if you do something like log die name, now we'll go ahead and run this, we get an error. You see that die name is not defined in ES module scope. The file is being treated as ES module because it has the JS file extension, blah, blah, blah. So ESM doesn't support die name. So that is the reason why we're trying to get it like this. This is how we do it in ESM. So instead of doing this, we see const directory name. It should be directory name is equal to path.die name, path.die name. And then we want to extract the directory from the file name. So now if we come over here and say we want to log the directory name, we no longer have errors. And now we only have the directory name, which is pointing to the utils. Now the file is in the utils. So this is basically how to do this in ESM. So if you want to have a separate function of die name, you just write a function, die name, and then you pass in okay, let's say you pass in a file name, which is a string, okay. And then you come here, you copy all of this, and then you say return die name. So that is a utility function that you can reuse across your application. So let's leave it here for now. So what next do we want to do? Now that we have our directory name and before I continue, I just want to say something. We won't be able to complete the app today because of time, because I can see there is a lot for us to talk about. And I don't want to rush. I just don't want to rush through everything. I want to carry you along so you understand how everything is being built, how everything works, and how we are going to building it. So now we need a class, a file manager class that we have methods that we can use to operate on our files. So we have class file manager. Now this class, we have a constructor. So we have constructor. So this constructor, we have directory, data directory, data file, and a default a method that actually ensures that data exists. So we have this this global, this is very annoying. I don't know why. Data directory is equal to path. So path.join, then we'll say OS home, OS or home directory. That is the home, our home directory, and then we join it to let's see, KC task manager, like this. So let's log this so we see what we are dealing with. So I actually want us to understand everything. So what is operating system home directory? So let's say OS home directory like this. Let's log it to the console. So as you can see, it's users coding symbol. So we had users coding symbols like desktop. So in users coding symbol, we want to add this directory. So we want our tags to be persistent. Actually, we're building it on it. So we want it to be persistent. You don't want it to, like, anytime we stop our app or we move this directory to another one, we don't want to delete our tags. We want to retrieve them anytime we need them. So we're joining. So if you log path join, then you do something like this, some path. Let's log this so you can see what this is as well. So as you can see, we have users coding symbol slash some path. So this is what we are doing. This will be in the coding symbol directory. Users coding symbol slash KC task manager. Great. So now that we've seen what we are doing here, we need another property. This dot data global this again. This dot data file is equal to, we'll say, path join, and this time around we want to place our path inside this. We want to place our tasks actually inside this directory. So what we do here, we say this dot data directory, and then we want to join it with our tasks. But this is like our database, so we want it to be persistent. That's why we're placing it here, so we don't have to delete it. And if you want to delete it, you can actually delete it as well manually, but you don't want to mistakenly delete it. Okay, so now that we have our this, there's another method here that we can use to ensure that anytime we create an instance from this file manager, we want to make sure that these directories and files already exist before we can perform any other operations. So we can see this dot ensure data directory. But if you try this now, you get an error because we've not created this method. So this will be an asynchronous method. They'll say ensure data directory. So we handle errors. We say try catch, and in the try block, we will say await fs dot access this dot data directory like this. So what we're trying to do here is we're trying to check if this directory exists. And if it doesn't exist, we will get an error. So we don't want to handle errors. What we're actually doing is if it doesn't exist, we want to create it. So we say await fs make directory. Which directory do we want to make? This dot data directory. And we want to also make it recursive because we have this is the data directory, and we have coding symbol this. So when we get to this place, we don't have this folder and we don't have this file. So we get to this place, it will make it recursive, then it will create this folder. And then if there's another subfolder, if you check if the folder exists, if it doesn't exist, it will still create it. So once you create this folder, then create the file. Then we'll make it recursive. Set it to true like this. So this is what this method does. Wow. Is it sorry if I pronounce your name wrongly. Is it Cassie or Casey? Am I being too fast? It's been a couple of minutes and we are still here. Okay, so I should slow down. How do you want me to slow down? Can you explain a bit? Am I talking too fast or am I being too fast? Oh, Are you just joining? Okay, so the thing is, I just want to carry you along, and after I'm done building the whole class, we'll still go over it again, and I believe by that time you understand better. But now what we are trying to do is to create a directory for our tasks. You know what a constructor does in a class? The constructor method, you know what it does in a class. So once we create an instance from this constructor, what it will do is it will make sure it creates a directory for our tasks, and it will also create um a file for our task, which will be this will be the directory, and this will be the file that will store our task inside. So we are also um, invoking this method here in the constructor to make sure that if this directory and this file doesn't exist, then we want not the file actually, this directory here, KC Task Manager. If it doesn't exist, then we want to create it. Once we initiate, we create an instance from this class. We want to actually we want this directory to exist, and if it doesn't exist, we will create it here. So that is what we are doing. So this class handles that. Now, this fs.access here is trying to check if the file exists. And if you try to access this file and sorry, the folder exists. And if you try to access this folder and the folder doesn't exist, it will throw an error. So we are not handling errors actually. What we are doing is if we encounter an error, that means the folder doesn't exist. And then we'll create the folder here. The reason why we're specifying recursive to be true is because we may have folders and subfolders. So we want to create those folders and subfolders. So that is the reason why we are passing the recursive to be true. So we have a method here that actually creates folder, our data directory, if it doesn't exist. Now we'll add another method to actually read tasks. So we'll call this one async read tasks. So this is also an asynchronous method. So say try, we'll add a try catch block. So in the try here, we say const data is equal to await fs read file. Read file. And for some of us that attended the previous class, we already know what read file is. So which file do you want to read? We want to actually read this result data file. Which encoding do you want to use? UTF-8 encoding. So we want to actually read this in human readable form. That's why we're using UTF-8 encoding. We want to read it in human readable form and not binary or base 64. So what are we doing here? We want to return the task. So we say return JSON parse, because we're reading from a JavaScript object notation file. That is a JSON file. So we need to pass the data so it can basically be like in JavaScript form or text or any human readable form, but not in JSON. We want to pass it from JSON to maybe normal object or normal text content to see data. So now after reading it, we are reading it and we're getting the data to be in JSON form. So we are passing it here. We pass it and then we return the data. So what if we encounter an error during this process? So we check the error code. So we say if error so if the error code is exactly equal to, if the file is not found, we get this error code. This one here. Is it annuent? Yes, annuent. That means we couldn't read any file like that. So if there's no file, or let's say there's no an error, but any kind of form, but if the error code is this, we'll just return an empty array. So this means either the file doesn't exist or content or the content is inside is not well structured or some kind of error like that. But if the error is critical and it does not relate to any of the file, not no content being in the file or the file being like not in existence, we just throw a new error, and then we see failed to read tasks, failed to read tasks. See error dot message, error dot message. So now that we've failed to read our tags, we've thrown error. So these are regular standard functions. So this is how we write production code. It depends on what you want, but you must handle errors, and you must make sure users of your application or other developers understand what's going on so that they can reuse your functions or methods. So now that we have the read task, all these are utility functions. Well, we've not started using them. We're just building them. So this one here, we make sure our data directory is created. And this one here, we make sure that we read tasks from our task JSON. And if we encounter an error, if it's a friendly error, like the content not existing or the file not existing, we return an empty array. Else, we try an error, then we try to know which error we've encountered by logging also the error message. Okay, so we need another method. So this method async write tasks. So this one here actually takes tasks and it's an asynchronous method as well. So we add a try catch block. And the try block, we make sure that our directory exists. So await this dot ensure data directory. We'll make sure that our directory exists. And anytime you see this method, just know that it's trying to make sure that if our data directory doesn't exist, then it should be created before we can go ahead and add tags to our file. Because if that directory does not exist, and then we cannot create the tags.json file, that is let's say the tags.json that we store our tasks, that means we cannot even create tasks in the first place. So we want to make sure that directory exists so we can create that tags.json file inside of the directory, and then we can be able to add tags to that file. So now that we've done this, now we are sure that the directory exists. Now, what you may be asking, what if the directory exists? Okay, we are handling that case. If it exists, and then nothing else, it's just like that. We are just making sure it exists. But if it doesn't exist, that's where it will create it. But if it exists, we will go ahead and then write a file to it. But if it doesn't exist, we will create it and then go ahead now to write file. So fs write file. Which file do you want to write to? This data file. Which content do you want to write to the file? These tasks, the tasks we are passing, this is separate. This method is taking a parameter of tasks, which we pass as argument when invoking this method. So we want to convert those tasks to JSON before we can save to our JSON file. Because if you don't convert it to JSON, we get an error because a JSON file can only store JSON content. So say JSON stringify. So now we say tasks. Convert these tasks to JSON. Nor is a function that we can take to operate on each task before adding to our JSON file. And then two, format it with 2 spaces. Okay, so if you look at this JSON file here, if you look at this JSON file, we have keyword. And this keyword in this array, it's formatted with a single space. If you look at the arrowhead here, this is an extension of how I configured my VS Code. So if you look at this, if you come over here and add a space, this is actually a tab. So if I add a tab, okay, so it's already configured. But what that space is, two spaces we do is anytime it encounters a sub key, like this bin here, this one here is a sub key. It will add two spaces and then indent it with, it will actually indent it with two spaces. That is what this one here means. This two here means, so you can make it 4 so that it can indent with 4 spaces, 1, 2, 3, 4, like this. But if it's 2, it's 1, 2. Okay, so let's change it back to 2. 2 is preferable. But this null here, this one is a we call the function, we call it a replacer function. So this function, we can take this we can add a function here that will map over all our tasks. And then there's something we want to do. Maybe we want to check that if the task is a priority of high, we just want to modify something inside the task before adding. But since we don't want to do anything, we just leave this here as null. And you can just do like this, and this will be fine. But so far as we want to add two, we want to indent it with 2 spaces, we must add a null and 2 like this. So we are good to go. So now we've created our task. So what will happen if we encounter an error during the task creation? We throw a new error. So inside this error, we say fade to write tasks. So we want to make our errors fade to read tasks, and here we say fade to write tasks. And then we'll try to display the message as well. So error message. So a user can see, or we testing our application, we can see why we're unable to actually write data to our file. Wow. So now we've completed our write tasks method. So we ensure that the data directory exists. And if it doesn't exist, this ensure directory, data directory, we create it. And then we'll go ahead to write data inside this file, data file, because at this point, it already exists. At this point, we're making sure that the data directory exists and the data file, the path joins the data directory and this task.json file. So that is clean. We don't have to worry about a non-existence, or we're handling that already. So now we have a function that adds tasks. This one, what this one does is it writes tasks. It's writing tasks to the JSON file, but we have another one that actually add tasks. Okay, so we have another async, and this one will say add tasks. So this one also will text the tasks that we want to add, and it's an asynchronous method. So since it is an asynchronous method, we can also handle errors. We say, let's just copy this one here. We don't even have to handle errors, because by the time we call this inside of this, and then we encounter an error, the error will be propagated to this throw a new error here. So we don't even have to handle error in the add task. So what we do is we say const task is equal to, we get the existing task in our task.json file. We say await this read tasks. So we want to read the existing tasks in our task.json file so we can make some modifications and restructure it. So say const new task is equal to, this is an object. So we want to add an ID, which should be unique. And we have a method of generate ID. But for now, let's say this dot generate ID, and then we pass in the tasks that we've retrieved, the existing tasks. So what we are trying to do here is maybe this our generate ID will look over the task and then it will get the length and then try to generate a unique ID based on the length or something like that. But we'll implement that just in a bit. So after that, okay, this should be task, no tasks, task. So after that, we'll come over here and then the rest of the task, we'll add the rest of the task and we will add a created add timestamp, which will be maybe let's say new date. Let's say to ISO string or to local. Okay, let's leave it to ISO. To UTC string. Universal coordinated time. To UTC string. And let's say no. To ISO string. Returns a date as a string value in ISO format. Okay, so let's leave it like this. And we add completed at no. Because we later update our task. If you want to update that the task is completed, this is what we will update this completed at. So basically, this is a single task, and then we can go ahead and see tasks. They will say push this new task we just operated on. So this task we're getting here, that is, we'll add this new task to the end, like at the end of the task. That's what the push does. It will append this new task to these existing tasks. And what we do here is we want to say await these write tasks. So we've read the existing task, we've operated on it, added another task to it, and then we want to write the task back to our task JSON. Then we see tasks. We've pushed this existing task to the this new task to the existing task. So what we are adding back is a task. And you may be asking, are we not duplicating tasks? No. The reason why is because why we are doing is because when you read and when you write, it simply means you are overriding the task, the JSON file, the task JSON file. So want to read it, add new task to it, then override it with the new content. So now that we've written to the task JSON, we will return the new task. So we can see the new task that we've added. So this is our add tasks function. First of all, we read the existing tasks. We will create a new task giving a user input. So we generate an ID, spread the user task, that is the description and other properties. Then we create the timestamp, created timestamp, then completed at which is initially null. Then we add it to the existing task. Then we save it to disk. We save it to the task JSON file. Then we return the new task that we've created. Wow. So moving on, this is where we implement our generate ID. Generate ID, then we take tasks. This is the task we are passing as argument to this generate ID method. So in this generate ID here, we'll check the length. You say if tasks dot length is exactly equal to 0, then we will return 1 because this is the first task that are trying to create. So we return 1. We don't want to do any other thing, just return 1. But if not, we'll say, okay, const the maximum ID. This is the new ID we want to create. Say math max, and then we don't want to modify. That is, we don't want to change things. We are following the pure function principles. We don't want to duplicate, or sorry, we don't want to how is it called again? Mutate data. We don't want to mutate data. So what we do is we just spread, we create a new array, and then we say tax dot map task. So what do we want to do now? We say task ID. So this is the max ID, the maximum ID. So you know what max.mask does is, let's say we have math.max of 1, 2, and 3. Now if you try to run this file, okay, task has already been declared, tasks push. Identified task has already been declared. There's 53. Okay. So we are just pushing tasks. Push. Const tasks. Tasks here. Push. Okay, so let's say const new, say updated tasks is equal to an array with tasks that we've retrieved and the new tasks like this. So we can say we want to write the updated tasks to file. Okay. So now I can see the error because of the comma there. Okay. So now it should work as expected. Oops. Max ID is equal to, JavaScript is frustrating at times. Okay, so let's clear the terminal and run it once more. So we can see 3. Math.max here, you are just saying return the maximum, like the highest number, which is 3. So we're spreading here and then we're mapping. This can actually, I think this can be an array. Then we can do something like this. So it still works. So what we're doing here, we are mapping just the IDs. The IDs are actually numbers. We're collecting them in an array and then spreading the array. So this is, for instance, if you have an ID of 1, 2, and 3, this is what we have at the end. After mapping it, we have this, and then we spread it in the math.max. So if we have 3 tags, and the highest, we have 3 tags, that means the highest ID will be 3. So it will return the max ID here will be 3. So we want to use the max ID, add 1, and then create the next task ID as 4. So we return max ID plus 1. Wow. So this is our generate ID method. So all we need to do now is to export default new file. And this is actually sweet. So our file manager here is actually, as you can see, the name here is file manager. And what we are doing is manipulating files. 1 minute, please. Yeah, so I'm back. Can you all hear me now? Okay, so now we have our class. So we can manipulate our files, create files, and write files, read data, and all of that. So essentially, this is our basic file manager. So I guess these are all the methods we need. Read tasks, ensure file directory is that, add tasks. Okay, so we have other method as well. We need to add method for updating a file, deleting a file, updating a task, deleting a task, and what else? I think getting a task by ID. So we have add tasks here. So our next method should be, this should be add task, not add tasks. We're adding, okay. So our next method should be async. And this one here will be, I think should be update task first. Update task. So this will take a task ID and update. Have the ID, updates. So the update say we will be the new content we want to update our task with. So okay, so updated tasks. Okay, sorry, that is a mistake. I was testing something I forgot to. This should be tasks, not updated. Thank you for the correction. Yeah. So here we have update tasks, and if you take the ID and the update we want to make, so we say const task is equal to await this read tasks. This global, this is annoying. We want to read the tasks. We'll retrieve the task. So after retrieving the task, we'll find the index of the task we want to update. So how do we find the index? We'll say, okay, const task index is equal to tasks find index. So how does the find index work? So this is the task we want to find its index. You'll see the task, we'll grab a task, and then we'll say the task ID, so the task.id is exactly equal to the ID we are passing. So if it matches, then it will return its index. So what do we want to use the index? So if it doesn't match, if the task is not found, If there's no task that matches this ID here, the index will be -1. That is, the index will be negative, -1. So if task and index is not equal to, or let's say, let's handle this case first. If it's equal to -1, we just want to return null, which means there's no task found with that ID you've passed in. But if there's a task found, we'll just grab the task using that ID. I mean, that index. So we have an array. Array have indices. Arrays are indexed, right? We have 0, 1, 2, 3. So if we have a task at 2, it's just like saying task 2. So we want to grab an element in this array at index 2. So whatever the task index is, it may be 2, 3, 4, 5. We want to grab an element at that and then update that element. So when we grab it, we'll see this is equal to tasks. We don't want to mutate it, task index. So we can actually come over and say, let task at index equal to tasks index. So we've grabbed it. And then you can come over here and say task at index is equal to, then you spread it here, task at index, and then you add the new updates. So what are the updates? We just add the updates. We just update our task with the new. This is the updates we are passing as, we'll be passing as arguments. So accept the parameter here as update. So after updating it, we will write it to await this write tasks. And then we write our task back to our task JSON file. So now that we've written it, we'll return the task at index. The task we just updated. We'll return it so we can see our task and the update. So this is how to update our task. So if we are using a database, this is where we find by one, find unique, or find first, we return it, update it, and then say database updates. So that is basically what we are doing. So update tasks, and we have async delete task that takes an ID. So we have const tasks is equal to await. First of all, read tasks. So we are retrieving the existing tasks. So we get the initial length to say const, not const initial length is equal to tasks filter task, and we'll check the task by its ID. Say task dot ID is not equal to ID. That is the task given. This is initial length, and this should be const filtered tasks. So we'll first of all get the length. Say tasks length like this. Okay, so now that we've gotten the task length and we've filtered the tasks, what do we want to do? Now, this will return the tasks that the ID does not match the given ID. So now what we will check the length. So if you say if filtered, filtered tasks length is exactly equal to initial length, that means the task doesn't exist. So if you return false, it means task is not found. Because if you filter this, that means if we have 4 tasks and the ID matches 1, this will return 3 tasks. And if we check the length here, we'll get 3. But the initial length of the task was 4. So the 3 will not be equal to 4. So this block will not be executed. So moving on, this one here we execute. We say await. We'll write tasks. This write tasks. Filtered tasks. Then we'll return true. Okay, this simple logic. First of all, we're getting the initial length of the task. So initially, maybe we had 4 tasks and we want to delete 1. So it will return 4. The length here will be 4. So we filter the task by the ID given. So if the file exists, this filtered task will return 3 tasks. That is, it will return without the one we filtered out. It will return 3. So we check if the initial length is equal to the filtered task. That means the task does not exist, because if it exists, it will be filtered out and the length will differ from this initial length. So if it's exactly the length, the filtered task length is exactly as the initial length, we return false. That task does not exist. But if not, that means the task exists. So we just write the filtered ones. We already filtered that one out. So when we write back to the task.json, that file will not exist inside. So it therefore means we've deleted it. So we just write the task back to the task.json file, and then we return true. So it's just a simple method, just simple logic. Just wrap your head around it, and that's all. So we can also get task by ID, get task. Then we pass in an ID. See const task is equal to await this read tasks. Then we'll say return task, find task, find the task that the ID matches the ID we are passing as a parameter here, which is equal to ID like this. So if the task is found, it will be returned. But if it's not found, we'll return null. So we'll say find. Okay, if you cannot find the task, then return null. That means the task is not found. But a task is actually, okay, no, not found. Let's leave it that way. So we can actually get all our tasks as well, or get stats. We can get statistics for our task manager. So we say async get stats. Then we'll say const tasks is equal to, and you may feel this is lengthy or these methods are just too much, but don't worry. You get to understand what this is. A standard kind of application, like the ones we've been using, that you say, okay, install this package from npm, run this method, get this. You see a red color, error, green color, or something we process, and this will do that, a package install, something like that. So don't worry, you get to understand why in a bit. Just understand every bit we are writing here and wrap your head around it. Don't memorize, but make sure you understand. So contacts here with, let's come over here, grab this one. Let's read our tasks. We've got our tasks here. Okay, so what next do we want to do? We want to get statistics. So we want to say const total, that's our total tasks, is equal to task length, the length of our tasks. Maybe we have 4. If we have 4, it will return 4. If we have 5, the length will be 5. So we filter out completed. We say const completed is equal to tasks filter. So say filter tasks, filter the completed tasks. Tasks, this is a callback function that says tasks dot completed dot length. So this will return an array. This should be task, not tasks. So this will return an array of tasks that are completed. So we just want to get the length. So the length, if it returns, if we have 5 tasks and 3 are completed, it will return 3 3 items in this array. And then if we add this length method, we get 3. The completed here will be 3. So we just want to make it short. We can make something like const length is equal to completed dot length, like this. So this is the same thing. Instead of writing something like this, just say dot length. Since this result will be assigned to this constant, we just get it from there. Okay, so moving on, we get a pending task to say const pending is equal to total minus completed. So if a task is not completed, it therefore means it is pending. So if you subtract the completed task from the total, you get the pending ones. So what we are doing here, we return total. Since you are just getting statistics, the statistics are the statistics of our listing. Completed, we return the completed one. We return the pending ones as well. That is in a number form. And then we say completion rate, which is the same thing as total. If total is greater than 0, I would say we just want to make it a round number, maths.round. And I will say this should be completed all over total times 100. Completed all over total times 100. Or 0. If the total is greater than 0, we want to get the completion rate. So this is in percent. If we have 5 tasks and we have 2 that are completed, we have 2 over 5 times 100 will give us the completion rate. Or if the total is not greater than 0, we just return 0 as completion rate. Okay, so now that we have our get start, we can have another method. This one is handy. You can say async clear all tasks. And this one is very handy and short. Say, okay, await these write tasks. And then we write an empty array. Just want to clear out everything. So once you write an empty array, the the JSON object and JSON file will clear the existing data and just add an empty array to it. So we don't have any data. We just have an empty array. So this is our file manager. Okay, so we can actually, I will document our class. I will document the entire file. Start by documenting the entire file. Document our class and one method. Then you get an idea how documentation works. Say file manager utility. Say handles file system operations for the task manager. They will say we'll add a small description. You say this module is responsible say for reading, writing, and managing. I think you should be managing the tasks data file. So once you get to this file, you just read it. Oh, okay. So this is what it's doing. So once you get to this place, okay, they've already told us what this is doing. So let's proceed. So when you get to the file here, you get to the method. And this method here, you see, ensure the data directory exists. Okay, so I want to document the one that returns something. This one returns something. Okay, so you come over here and you say, okay, exactly. I like JS docs. Now we say read all tags from the data file. Read all tags from the data file. And then here, this returns an array. You see array of tasks. Wow. Now if you hover over this, then you can see this is and then I will show you how important documentation is. Anywhere this function is used, if you hover over it like this, you see what we've documented. Read all tasks from the data file and this. So once you hover over, maybe you've forgotten what the read task file is function is doing. Then you hover over it like this, you see that it read all tasks from the data file and it returns an array of tasks. So once you see it like that, you don't need to see the function, the method implementation details. Once you see the docs, maybe you've forgotten how to use it. Oh, so it will read all the tags from the data file and return an array of tasks. Okay, that means it will return all the data. So you go ahead and use it instead of checking the implementation details. That makes documentation important. And if you hover over this one, ensure that data directory exists. So anywhere you use it and you hover over it, you see this. So that is the importance of documentation. Which is in the utils. So the utils now we have three. So the next one here will be the formatter. It should be the formatter. The next one should be the formatter, I guess, because we will need to write the formatter before the validator. So this we format our input before saving to our file, and then this will validate our input. So let's look into the formatter. So now we handle let's document this one first before writing anything. So let's say it handles formatting, or let's say it handles all output formatting, and colors. And then we say and display logic for the let's say application. It also provides consistent styling and user friendly output. Like this. So what is name? Say class, they will call it formatter. Okay. So our formatter function also has a constructor. So this constructor has an object of colors. That is ANSI colors. So these are colors for color codes for terminal output. So we have this dot colors. Global this. This dot colors is equal to object. Then we have reset. This should be red. This one be red. Guess red. We have bright. We have bright. Then we have dim. We have red, green for success, green, red for error, green for success, yellow for warning, blue for okay. So I guess we should just stop here. Maybe we'll add more later when we need them. So copy this one as well. Bring it here. Bring it here. 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 So change this to, this one is X. The bright should be, oh, X1, B, 1M. So these are, as I earlier mentioned, these are ANSI color codes for terminal output. And Ngozi, so maybe you didn't hear me. But let's quickly. Okay, so we can see. So I want to ANSI escape code. Okay, so you can see this one here is Unicode, this one is hexadecimal. So basically we are using hexadecimal values. Set styles to, this one is bold. If you add 1 in front before this, it means it will be bold. Sequences, so you can see all the values, hexadecimal values, the escape and everything. So you can find time to go through all these things and maybe see other formats as well. But this format is better. This one here. So we have 1M. So the dim now should be dim is 2M. Red is 31M. Yellowish green 32M, I guess 32M. Yellow 33 and blue 34. So we have our colors for formatting. So the next thing is priority colors. So we need to, because our task, we have priorities. We have high, medium, and low. So we have these priority colors is equal to, then we have low. The low priority, we have these colors blue. Okay, the first one, this colors blue. So medium priority, we have these colors yellow. And high priority, we have high priority. Red. And then we have the status symbols as well. Status symbols. This will be pending. And pending should be, let's see if we can, pending. Oosh. It should be a sandbox. Okay, I think it's this one. Let's use, okay, this one, let's use this one. This is pending. And then we have completed. Completed, let's use this one here. Okay, so these are the symbols on our terminal. This is what we'll be getting on our terminal. So we are actually almost out of time. But let's add one method. This is our constructor. And below the constructor, let's actually document this one too. So we have this will colorize text with specified color. So we have, it will take some parameters. So we'll say at param. The first parameter will be a string, which is a text. So what this does is text to colorize. This is the text we want to apply those colors on. So there's another parameter. This one here is also a string, because this one should be the color we want to apply to. What's this? This one here should be, this one is the color we want to apply to the text. So let's say color name. So what does this method return? It returns a string. So the string is a colorized text. So let's write the actual method. Say colorize that text in text color. So say const color code is equal to this. Please, you should stop drawing on the screen, please. These colors. So this is the color we want to, this is the color we want to apply to the text. But if there's no color, we want to default to these colors. Reset. We want to default to the reset color. So what we want to do is we want to return a string, which is actually the colorized. We say color code and the text, and say these colors reset. colors reset. So this method here actually colorizes text. So if you hover over this method now, you see the documentation. Colorize text with specified color, params text, text color, and then you see the function, the formatter.colorize here. You see the documentation. So it's easy to comprehend and use. So the next method we want to write will be a lengthy method that will format task actually. We have a couple of methods here. So in this case, we are out of time, but we made progress. We've made progress, but we still have a lot of work to do. So this is basically an app that we're building. So for today, I think we'll have to stop here. If you have any questions, you can go ahead and ask. Any questions so far? If you have any, go ahead and ask. Yeah, Casey, you can go ahead.
Okay, Ella, you said that you wrote over it after you're done.
I did what?
I said earlier, you said you go over it when after you are done.
Okay. Okay, so let me quickly go over the file manager. So what the file, the name file manager means we'll be manipulating files, right? So we actually write to file, read from file, and all of that. So here, the first method in the constructor here makes sure, or let's say the first property here, make sure that the folder in which we'll be placing our tax.json exists. And then this one here is actually the file in which we want to write to. So this method here in the constructor, it actually means once we create an instance from this class, this will run and it will make sure that this folder exists. The folder we want to write files inside exists. So this is the method that we're calling in the constructor, this ensure data directory. So we want to make sure that the folder exists. So fs access here is checking if the directory if it doesn't exist, it will create it with its subdirectories. So that one there, they are all utility functions. So this one is read tags. We're using this to read from our JSON file. So fs read file here is a method on the fs, the file system that read from a file. So we are reading from a file. In our previous class, we discussed what the encoding is and all of that. So we can watch the previous video to understand the encoding. So we are reading the file in a human readable form, not in binary form or base 64. So we're passing it and returning it as either text, not JavaScript object notation, because the file is stored as JSON. But after reading it, we return it as text. So if there's an error, a friendly error, if the file doesn't exist or the content is kind of corrupt or something, we return an empty array. But if the error is critical, then we log this to the console to enable the user know that, okay, we've encountered a critical error, or the developer, so that they can check and see why that threw an error. So we have write tags. So we want to write a task. Actually, write tags here, it will write to the task JSON. But before we write, we must make sure that that directory exists. And if it doesn't exist, we'll get an error. So that is the reason why we make sure it exists. And if it doesn't exist, this method here creates it for us before we can go ahead and write to it. This write file here, this write file here is a method on the fs, the file system. So we're using it to write this file, and it's to write to this file. The first argument is the file we want to write to, which is task.json. If you come over here, you can see the directory to this file, because the file will exist with its complete directory, task.json. So we want to write to the data file, and then this is the content we want to write. We want to turn it to a JSON before writing to it, because the file itself it has a JSON extension, so it only stores JSON data. So we want to convert it to JSON before storing. So in the process of storing, maybe there's an error or something like that. We'll throw an error. So the developer or the person writing it will know that, okay, while writing this file, I encountered an error. Let me try again. Or if it's a developer, he will try to fix the error. So we have the add tasks here. So the add task basically reads task first, operate on the new task they want to add. That is this parameter, this task parameter here. It will operate on it, add an ID, create the created update. It will add the created update and add another property of completed at which initially is null. Then it will add the task to the existing task. Then we'll write back this task to the JSON file. Then we'll return the new task that we've added to these tasks. Because when you add something, you want to return it and see that, okay, it's successful. If it's successful, I want to see the task I've added. So we will just show it to you that, okay, it's been added and here's your task. Okay. So this one we can update task. So if we want to update task, we read the existing. The reason why we are reading first is because if you write to that JSON file, it will override everything. That new thing that we've written will override everything in the JSON file. So first of all, we want to read the content that was there before. So after reading it, we'll operate on it and then we'll save fresh content. That means anything we've done on that content, we'll save it back and then it will override the old content there. So after fetching it, the task here is an array. That's why we're performing array, we're applying array methods on it. So we'll first of all find the task index. So in JavaScript, finding index is actually task here. Then we'll call the array method of find index. So this find index here will accept a callback function with a parameter of task. So this task here, we grab the task ID and then we check for every task. We compare it with the incoming task here. So the first task that its ID matches this ID we've passed here as a parameter, that is the task we grab its index. Let's say it is the second task that the ID matches this ID we pass as a parameter. That is the task we return its index. And it's at index what? If it's the second one, it's at index 1 because array indexes it starts at 0. So we have 0, 1, 2. So if it's the second one, it's at index 1. So that is when we say, okay, the reason why I'm saying task at index here, we pass in is just that if it's at index 1, we assign that 1 to this task index. Okay, so here is a mistake. This is task index like this. This task index. So if no task is found with this ID that is being passed as a parameter, task in the find index method here always returns -1 if no task is found. So if it returns -1, it therefore means there's no task with that ID you've passed. So we return null. That's we cannot find any task. But if it returns an ID, a task index, so we use that index to grab that task in the array. So we've already found the index of the array. So just pass the index directly. So if it's at index 1, we pass here and then we grab the task at index 1. So that's the reason why I named it as task at index. So now we want to modify this task at index. So we say task at index is now equal to, we don't want to mutate data. So we want to create another object. This task at index is actually an object because this is an array of objects. So we grab this object and then we will create another object and then reassign to it. You say this is another object. We'll spread the existing object. And then the update you want to update, the update you passed as a parameter, we pass them here and then it will override some of the properties. Let's say if this update contains a description. So if you spread it here, this new description will override the existing description. So all the things we've specified in this update will override the existing ones. So now we have a fresh um okay, task at index spread updates. Task at index tasks. So there was a mistake here as well. Tasks, push task at index. So now we've updated it and then we'll add it back to the tasks. Then we'll write it to the file. So after writing it to the file, we'll return the task we've updated. That is the task at index, which that is the one we've updated. So this is basically how to update a task. So we want to delete, but if we want to delete, we'll first of all read the tasks, and we're out of time. So after reading, we get the initial length and then we filter out the one we want to delete. So after filtering, if the length is the same thing as the initial length, that means no task exists with that ID. So we return false. But then if the length is different, we'll get past this block and we get here, we'll save the filter task. That's we've removed the one we want to delete. We'll save it and then we'll return true. Get task by ID, so simply grabbing a task by ID using the array method find. But if the task doesn't exist, we return null. This one is get stats, getting the statistics of our application and all of that. This one is resetting our application, and this one is generating an ID. So maybe the reason why you're not understanding is because this is a combination of basics, the basic things we've discussed about, and some we've not even discussed. But it's you are supposed to know them as an intermediate. You are supposed to know all these JavaScript simple things like the array method and the rest. So maybe you should go over it, and anything you don't understand, maybe the math marks, just check MDN docs or check. You can ask questions on the Discord channel, and we'll answer you. Okay, so we've come to the end of today's class. Um, if you have any questions, please drop it on the channel so we can